Today let's start with a new topic, electric field and electric field intensity. Electric field intensity and the electric field. Let's deal with this electric field intensity first. What is electric field intensity? They are defined as the force experienced by a unit positive test charge. We say E vector is equal to F vector upon V naught. This is a vector quantity. This is a scalar quantity. This E is going to be a vector quantity because the direction will be along direction of this force. If force is measured in Newton, charge is measured in Coulomb, so the SI unit of electric field intensity will be Newton per Coulomb. The force on a charged particle placed in the electric field is given by F is equal to Q into E. Let's derive dimension of electric field intensity. We say dimension of E. Let's calculate this. Since E is equal to F upon Q, dimension of F will be mL t to the power minus 2 upon A into T. So we left with mL t to the power minus 3 A to the power minus 1. Coming on to the next part, let's talk about electric field due to point charge. Electric field due to a point charge. What I've taken positive charge Q at point O. I've taken a unit positive test charge at point P. Since both are positive, direction of force will be acting outward. The distance between O and P will be R. Between these two charges, let's use a Coulomb's law. Using, we can say Coulomb's law, the force between two charges is given by F is equal to 1 upon 4 pi epsilon naught. It's Q naught upon R square Newton. But we are supposed to find the electric field intensity. So we can say since E is equal to F upon Q naught, put the values 1 upon 4 pi epsilon naught, it's Q naught upon R square, Q naught, cancel this, you're left with unit will be Newton per Coulomb, and you're left with E is equal to 1 upon 4 pi epsilon naught. It's Q upon R square Newton per Coulomb. This is the formula you're left with. In vector form, you write this as E vector is equal to 1 upon 4 pi epsilon naught. It's Q R square R cap. Right? If there are group of charges present in a space, for group of charges, total intensity becomes E vector is equal to E1 vector due to first charge, E2 due to second charge, E3 due to third charge, E4 due to fourth charge, plus En due to n number of charges. We may write this as E vector is equal to 1 upon 4 pi epsilon naught summation I is 1 to n Qi upon Ri square Ri cap. This cap is known as a unit vector. This sign summation means you're adding all the charges together. Coming on to electric field. Electric field is a space around a charged particle where a charge can experience a force of attraction or repulsion due to the presence of another charge. This electric field, beside this electric field, there are two other electric fields like gravitational field due to a massive body such as, you can say, Earth. Second, magnetic field due to a presence of a magnet. This electric field is due to electric lines of forces. Now let's deal with some properties of these lines of forces. The very first property, they start from positive charge and terminate at negative charge. Second, they are imaginary. They are imaginary lines. Third, they never intersect because they are parallel, because they are parallel to each other. Fourth, if you draw a tangent to any of these lines of forces, shows direction of the force. If a tangent is drawn on any of these lines of forces, then they shows the direction of force. Coming on to some diagrams now. I've taken positive charge, I've taken negative charge. Lines of force will go outward. As I told you earlier, they start from positive, and in case of negative charge, they go to terminate. First diagram. Second diagram, if the two positive charges placed very close to each other, lines of force will go outward. You can see they are repelling. Second diagram. The third diagram. I've taken both negative charges lines of force will come towards the negative charge. If this is third diagram, and if one is positive, another is negative, lines of force will go like this. This is the fourth diagram. After this, I'm going to start with electric dipole in my next video. Thank you.